Hey there everyone. We're here today to learn a little bit about the power law and especially how it's used in electricity. So we're going to see that. We'll see that there's some equations that kind of tell us a little bit about how the power law works. So let's go over and look at kind of an example of how power law could be used. So I've drawn here a toaster, and a toaster is probably something that most of us are really familiar with. And if you look at any appliance, really, for that matter, most likely you're going to find somewhere written on that appliance something to the effect of a power rating. And let's just say, for the sake of our example here, that this toaster had it was a 100-watt toaster. So watts, first of all, is the unit of power. Now, what I want you to think about when you think about watts, think about this as how much energy is used in a period of time. All right, so the higher the watt rating, the more energy is going to be used in a given period of time. So 50 watts will use half as much energy per time as a 100 watt. If this was 200 watts, it would use twice as much energy as a 100 watt. All right, so of course what's happening inside the toaster, if you could kind of slice open the toaster and you could actually take a look inside of it, when it's turned on, you have these little tiny wires. And as electricity passes through these little tiny wires, they use up some of the energy that those electrons that are passing through have. And as they do that, they actually heat up. Of course, as they heat up, the toaster does its job, which is toasting our toast. So now that we understand what the power is really looking at how much energy is used in a given period of time, let's take a look at the equations that actually we're going to be using here when we talk about the power law. So when it comes to electricity, power equals the current times the voltage of the source that's powering the object. So once again, we've already kind of mentioned this, but P is power, and power is measured in watts, as we've already said. From previously, we've learned that I represents current, and we of course should know at this point that is measured in what's called an ampere. We often just say amps, and we'll often abbreviate that with just a capital A. V, of course, we've mentioned this as being something called electric potential, and we commonly call this voltage. And of course, this is measured in volts, which we abbreviate with a V. So if I wanted to calculate the power of something, if I knew how much current was flowing through it and how much voltage there was, I can actually calculate the power in watts down here. And I did mention there is a second equation that we're going to use, and this equation is actually derived. But by derived, I mean we're going to do some algebra to actually find this other equation. So the other equation that we're going to use actually starts with using Ohm's law and also this power law that we just wrote down. If you notice here in the power law, we have voltage. Well, Ohm's law, as we write it, is written as voltage equals I times R, current times resistance. So voltage and current times resistance are the same thing. I can take this and I can substitute it in over here into this equation. And I'm going to go to a new slide and do that there. Alright, so we started with our power law, which is P equals I times V. As we just mentioned, voltage is equal to I times R from Ohm's law, so I can substitute that in right here. Again, this V right here is equal to I times, oh, that's supposed to be an R. Let me fix that. Let's get an eraser. going to let me erase. Nope, it's not going to let me erase. Okay, so let's just change this into an R. There we go. So again, this V right here equals I times R. Now, when we do the math here, you're taking I times this quantity I times R, and you're going to get an I times an I squared. Or these two things are going to multiply to give us an I squared. So we're going to have I squared R equals the power. So our second equation that we're going to use for power law is P equals I squared R. Our first equation that we're going to use for power law is P equals I times V.